And now we get some more applications of angle addition and difference formulas. So these next couple examples are among the best that I can give you because they use a little bit of geometry and, well, diagrams to solve them. So it says find the exact value, so exact meaning non-decimal, of cosine of alpha plus beta. Okay. All right, so I know that this is equal to, right, cosine of alpha cosine beta minus minus sine alpha sine beta. And so great, I just need to figure out what each one of these are, and so I know sine and I know cosine, so I could substitute those in. But I don't know, right, like I don't know cosine alpha. So that's where we should take the given information, okay, this whole big chunk, and make a picture. Okay, so for instance, if I make a picture for alpha, okay, alpha, so here's my grid. So I know alpha is between pi over 2 and pi, so that puts it in quadrant 2. Okay, so I have something like this. Alpha would have terminal side in quadrant 2, and I know that for this particular angle, right, sine is 5 over 13. So again, I could make a little reference angle there. And then opposite of the reference angle in quadrant 2, I'd have a side of length 5, hypotenuse of length 13. And I could use the Pythagorean theorem to figure out that the adjacent side is negative 12. Okay, so you can do that on your own. All right, so that's a picture for alpha, and that's going to be helpful. Now I'm going to make a picture for beta. Okay, so beta, it says beta is in quadrant 4. Okay, so this angle here would be beta. I again can make a little triangle. Okay, this would be kind of the reference angle. And then in this diagram, beta, cosine of beta rather, would be 5. So adjacent side is 5. Hypotenuse is length 6. And then you can find that the other side would have length square root of 11, but then it's negative due to the quadrant. Okay, so those pictures really help because now I'm able to go back and substitute the values in to what I found, or into this equation that I was originally working with. Okay, so cosine of alpha. Okay, in this picture, if I look at the diagram and evaluate cosine, I get negative 12 adjacent side over hypotenuse 13. Cosine of beta, okay, need to go to the other diagram now, over to this one. Cosine would be 5/6 minus sine of alpha. Okay, so alpha diagram, figure out sine, 5 over 13. Sine of beta, let's see, going back to the beta diagram, that is negative square root of 11 over 6. Okay, so then I can go forward and evaluate this. Negative 60 plus 5 square root of 11 all over, and then 6 times 13, might have to get out a calculator to do that, negative 78 positive. Okay, so there we go. We have found the value of cosine of alpha plus beta using angle addition, and this other information, I put it into a diagram. Okay, so I recommend doing it this route only because it is a little bit more visual and you can see where things come into play. Next example, okay, I'm going to do effectively the same thing. I'm going to call this angle, like my alpha angle, because inverse trig functions, right, they are representing an angle. And so this arctangent would be like my beta, okay? So the only caveat is that we're not given additional information to help us figure out the quadrants, but I think we have enough. Okay, so I'm just going to get kind of grids started. Okay, so sine inverse, right? So sine inverse, remember that's restricted to quadrants 1 and 4. And so in these quadrants, I know that if I said alpha was equal to sine inverse of negative 12 over 37, then that would actually give me that sine of alpha is negative 12 over 37 within this region. So if sine's negative, that means it's over here. So alpha is technically this entire angle. I can look at its reference angle here, and then in this diagram, right, I can drop an altitude to the x-axis and say that in this triangle, sine, which is the opposite side to adjacent side, means that opposite side is minus 12, adjacent side is 37, and I can find the adjacent side as 35 using the Pythagorean theorem. Okay. Next one, okay, arctangent, and again, arctangent is restricted, or I guess when we were working with arctangent, the restriction is still quadrants 1 and 4. Okay, so I'm in that region, and again, following the same logic as before, I could say, okay, here beta is equal to arctangent of 5 over 12, meaning that tangent of beta is equal to 5 over 12. So tangent is positive, and so among these two quadrants where tangent is positive would be quadrant 1. So this would be my angle beta. Okay, drop the altitude, and then in this triangle I can label the opposite side as 5, adjacent side as 12, and then we can find that the hypotenuse is like 13. Okay, and now I have my diagrams to go forward. Okay, so what I'm going to say is that cosine of alpha plus beta, okay, where alpha is the sine inverse and beta is arctangent, this would be according to the angle addition formula, cosine alpha cosine beta minus, sine alpha sine beta. So now I just run through and substitute information in. Cosine of alpha, 35 over 37. Cosine beta, 12 over 13. Sine alpha is negative 12 over 37. Sine beta is 5 over 13. Okay, and now we number crunch. And so I did the calculation off video, but it ends up being 480 over 481. Okay, so darn near 1. We would just be a few digits off. But so another scenario where setting it up using diagrams can be useful. We just have to recognize that inverse trig functions produce angles. All right, this last example, I'm going to say is optional. Okay, so if you want to stop the video here, you sure can and move on with your life. Or if you want to kind of stay tuned and see, why do we actually need this stuff in actual application? This comes into play when you're working with physics. Okay, so we have a scenario, right? We have a 1 kilogram object at the end of a spring oscillating, so just meaning it moves back and forth according to this particular equation that we're given, right? And so we're looking at horizontal position from its resting position. And we want to express it in this compact form, okay? So how do we do this? Well, first of all, we want to recognize that when we have sine of t plus alpha, right, sine of t plus alpha, that would be equal to sine t cosine alpha plus cosine t sine alpha, okay? So now I really want to figure out what k is and what alpha is, if at all possible. Okay, so now I'm going to write what I'm given right below it. So I'm given that x of t is equal to negative 3 sine of t plus 4 cosine of t. Okay, and now this might take a little bit of time to recognize. Okay, but I think we're given some information. Okay, we are given that, when I look at this, -3 seems to be the value of cosine, and sine seems to be the value of 4 because I have, cosine t appearing right there and sine t appearing right there. Okay, I mean, this is problematic though because these are not in the ranges of cosine, right? Or cosine or sine. Sine and cosine are between -1 and 1. So how do we work with that? What we're going to do is do a little analysis. So I'm thinking, and I would just kind of want to set up a little diagram. Okay, so here I know that so I'm just going to make notes. So cosine alpha is equal to -3. Okay, it's not actually -3, but it's just going to help me with placement. And then sine of alpha is 4. Okay, but anyway, cosine is negative, sine is positive, and I think that's actually maybe the better takeaway. So cosine is negative, sine is positive, and so that's going to put us in quadrant 2. So we can imagine that we have this angle alpha in quadrant 2, okay? And so here, I could say, at least in this diagram, right, cosine is the horizontal, so -3 and 4, and then this would actually allow me to say, okay, well, complete the triangle and say that this is 5, right, in order to obey the Pythagorean theorem, okay? So really, we're saying that in this triangle, right, cosine of alpha is equal to -3/5, and sine of alpha is equal to +4/5, okay? So then what's going on with this x of t? Why is there no 5 appearing? Here's the thing. There's a common, I don't want to say trick, method, maybe in mathematics, where we multiply and divide by the same number because it doesn't change the expression at all. Okay, so really what I'm saying that x of t is actually is 5, and then I'm going to move this 5 and the 5 that's in the denominator into each term. It'd be 5 times -3/5 sine of t plus 4/5 cosine of t. Okay, and now I have this expression as cosine of alpha and this as sine of alpha. Okay, and out of this whole thing, I think I have k appearing too. So what I'm actually saying here is that this 5 is going to stay out front, and this expression in here, the -3/5 sine t whatever, right, that is the same as sine of t plus alpha, because I kind of started working backwards. Okay, now the only thing that remains is I need to figure out what alpha is, and so if I look at finding alpha, right, in this diagram, alpha would be, so let's see, to find alpha, I could do an inverse function, right? So I could solve for alpha in either one of these. The only problem is with sine, I run into issues because this, again, sine is defined in, or inverse sine is defined in quadrants 1 and 2, or sorry, 1 and 4, and so our angle's in quadrant 2, which isn't going to work. So that's why I'm going to use the cosine and solve for alpha in that. And if I do that, right, I apply the inverse function on both sides. So alpha would be cosine inverse of 3/5. Okay, and that's how I would end up leaving my answer. So I have it in the form where 5 is k, and then this whole thing here is our alpha, or as our angle alpha. Okay, and so in physics, this is another way that we can just express a displacement function.